It's the first half over and done with. I do hate poker win.
Do you?
Yeah.
Oh, I think you're doing really well.
Yeah.
You know, I've been watching, and I think Lord Hawkenstein has no idea what you are. He's looking at you and just sees you as a regular dealer. He doesn't know anything.
That's cool. I think we're tricking Mr. Sir Lord Hawkenstein quite well.
Yeah, I didn't know it was Sir Lord.
Yeah.
He's got quite the title.
Yeah, he's got a very big title.
Question though, if you're the dealer, why haven't I won a single round yet?
Well, Wayne, it's all part of my plan. For us to see the enemy's weaknesses, we must first make them win, so they think they're invincible. And then when they think they're most powerful, we knock them down.
Oh, so that means in the second half, are you gonna slip me a royal flush?
Maybe.
Yeah?
Yeah. Oh. Alright. Now on to simultaneous equations number 1.
Yes, they do it twice, and it's two entirely different methods of doing a similar thing.
Yeah.
So
first, what is a simultaneous equation and why be using it?
It's a good question. I'll solve it right now.
Love it.
So we have two straight lines like this. Now they intersect at this point, and because they're linear straight lines, they will never intersect again. They'll just go on infinitely away from each other. And if I ask you what is the point of intersection, there's a jazzy little way of working it out. Now simultaneous equations means there's two equations that run along each other. So
we need to simultaneously equate them. Now there's a few ways of doing this, and this way makes most sense for the name. It's making them two equations essentially equal, but we'll get onto that later. So first we need to have the two equations.
We do, because we can't do anything with that now. We have no information whatsoever.
Apart from the gradient-ish.
You could work it out if you had values along here.
Yeah. So this one could be y equals minus 2x plus 6.
Okay.
And the other one could be y equals x plus 3, say.
Okay. So, firstly, before we go on to working out this, we can say that we know that this one, even though in this case Triv's kindly pointed it out, in the exam it might not. You see it as a negative 2x, that means it's going downwards.
Yes, it gives you 2, you will know which one it is going to be, so it'll be the one with the negative line.
And plus 6 means it goes through the y-axis at 6, so that point there is going to be 6.
Equally.
And for this one, no, it's going to be 3.
Yeah.
So this point here is going to be somewhere in between 3 and 6 in the y area. So when we get to our answer we can have a look and say, yeah, it's about there. So it's a bit of estimation.
Yeah, use your estimation sort of see your answers. Good, alright, let's do it.
Okay, so first step is to get the algebraic terms on one side and the constants on the other, as it were.
Okay, so what Wayne's going to do now is going to put the 2x minus 2x at the other side by plussing 2x and the bottom minusing an x. What we want to do is get rid of one of our two unknowns. Our unknowns are the y and the x, and each have a different coefficient. What's the coefficient, Wayne?
The coefficient is the number in front of the unknown, Truth.
Absolutely.
So this coefficient is 2, this one's minus 1, and these two are both 1.
Yeah.
Now, to eliminate these, you'd have to plus or minus them. So I can see that if we do a minus here, because both of these are invisible 1, if you do 1 minus 1, it would get rid of the y's entirely.
Yeah, then you can just deal with the x's and work out their value.
So what we're doing is a big subtraction of all of the things in each of these equations. Y minus y is 0y.
Yep.
2 minus minus x.
Same as plussing it, so it becomes 3x, and 6 minus 3 is 3.
So you can now go ahead and ignore the 0y, because anything times 0 is 0. So we've got 3x equals 3.
So we divide both sides by 3, a common factor, and we get the answer, which is x equals 1. But then we don't stop there, do we?
No, because we want it in coordinate form, we're going to need an x and a y value, and we only have an x.
Yes, this will give us our first bit, so we have our 1, but we still don't know our y bit. But we don't have to do all of this riff-raff again of getting rid of an unknown. We can put it straight back in.
Yes, because you'll notice here we said we have two unknowns, as do we here, here and here. Now we know an x. The only thing we don't know here is y. We can put the x value where it says x, and just have 1 plus 3, which is 4. And it happens to be y equals that. So y would be 4.
It would be. And with our estimation we can tell that between 3 and 6 it does look about right.
Unfortunately it doesn't stop there though.
It doesn't, it gets more complicated than this. You got a tricky example, Wayne?
I have one in mind.
Alright, I'll start writing stuff off.
Okay. So, I'll just write this up. I'm not going to bother drawing you an axis like this. I'm just going to give you two simultaneous equations and ask you to solve it. Is that okay?
That's right. Sometimes they won't give you an example of axes, they'll just give you a question. Sometimes they'll just give you an axes and they'll combine linear stuff as well, but that's less likely to be an end question if it's that. So this is all A star, A star. It's quite tricky, but it's good to get good at it because it gets lots of marks in the exam. Ooh, okay.
Those are your two simultaneous equations. They don't always give you it in the y equals form. That's a friendly format. This is your A to A star level stuff. They like to rearrange it already, so it's already in a form that Triv's going to want it, but the coefficients are not easy. You can't just plus or minus these. You'd then still have two unknowns.
Yeah, which is where it gets a bit tricky, but there is a trick for these tricky questions. We can times the coefficients so they are one of the right numbers as long as we do it to the whole equation.
Yes.
So, what do you think is the easiest way? We can do two things that are very similar. I think we're going to get the x's to be the same this time.
That would make sense.
So I can see a common factor that these are going to go up to, and it's going to be 6. So to get this one, the 6, you have the times by 3.
It's good to write these little notes to yourself what you're doing.
And this one you'll have the times by 2. So right over here, what are they going to become?
Yep.
So 2y times by 3 is 6y plus 6x.
Equals, and then 9. 3 times 3 is 9.
Still on plussing.
Then we times all of this by 2, so you're going to have 12y plus 6x equals 8. Now you'll notice what Triv's done, as he was explaining, is he's got the coefficient of the x's the same. You don't always have to get the y's the same and eliminate them. Either do.
Yep.
And if you've got both of them plus, you're going to minus one from the other.
Doesn't matter which one you minus from.
No.
But we'll do minusing the top one from the bottom one.
Yep, so...
That's really awkward, isn't it? Actually, the bottom one from the top one. So the 6x's, they disappear, so we're going to have a 0x here.
Yep. But you know eventually you're going to just ignore, because anything times 0 is 0, which is the point.
Absolutely. Now, we have 6y take away 12y. That is a minus y, but don't worry about that. It's not too bad yet.
No. And then 9 minus 8 is simply
1. So, now we want to get rid of this minus, so we swap them over.
Yep.
So it becomes 6y equals minus 1. Then we divide both sides by 6. Into y equals minus a sixth. This is quite mean, but it might be in the calculator paper, so it won't be that bad. Then we do the same what we did before, so we put it back into one of the equations.
I think this one's your easiest one.
I
I think this one
yeah,
actually.
I reckon you're right.
Because it's a sixth, if you times that by 6, it's just going to be 1.
Alright, so let's do that. So we have 6 lots of minus a sixth.
Which you're replacing the y with your now known y.
Yep. Plus 3x equals 4. So that will end up just being minus 1 plus our unknown, 3x equals 4. Add 1 to each side, 3x equals 5. And then divide both sides by 3.
X equals 5/3, and I'd leave it in that form. 5/3 is your final answer.
And then you have the coordinate of 5/3.
And minus a sixth. Alternatively, what you could have done is, rather than equating the x's to get 6x, you could have times the top one only by 3.
Yeah.
So you'd get your 6y plus 6x equals 9, because you times it by 3 here. Then if you just leave the bottom one, you might notice 6y plus 3x equals 4. Then you can get rid of the y's instead of the x's, and you get 3x equals 5, and it would all boil down to the same thing.
We'll get the same answer.
X equals 5/3, just the same as here. And if we went on to find the y, it would come out to minus a sixth as well.
Because there's only one point they intersect at. It would be the same both orders, but it depends what way you think is easiest.
It is so. That's simultaneous equations 1. There is a second one with another method.
There is, but until then I think we need to get back to our cards.
Okay, I don't mind losing a few more, but please, steal me in right eventually.
You don't need your money, do you?
No.